Hey, hello lovers of natural history. Bob Ellis here again with another episode of Notes from the Field. And today we're out here at Graver's Wash, which is in the Mogollon Highlands, kind of the northern central part of the Mogollon Highlands. And Graver's Wash is right on the edge of the Apache Creek Wilderness and very near the Walnut Creek Education and Research Center. And it's known for its old growth ponderosa pines. This is just one of many out here. And surprisingly, that's not what we're here for today. I wanted to show you something else. I wanted to show you something that is important to all naturalists. So come along, let's look at it. So what I have to show you has something to do with one of the most revolutionary ideas in human history. And I would argue that probably the most revolutionary idea in human history, with maybe the exception of Einstein's theory of relativity. And that is Charles Darwin and Alfred Russel Wallace's revelation of evolution through natural selection. Now, I want you to think for just a moment what this world would be like without the evolution as a guiding framework. There would be no modern medicine. There would be no exploration of minerals that was using advanced technology. So we'd be kind of stuck in the Roman era of mineral exploration. No CRISPR technology, no genomics, no vaccines, as a matter of fact. So this framework of evolution, for some people, is really hard to grasp. And I think I know why that is. Because humans, in general, most humans, struggle with the concept of big numbers. Now, for example, I can easily kind of understand maybe the time period of 3 generations past. But once I get past 3 generations of my family history, I sort of get lost. Or another example, I can sort of conceptualize numbers around my gross annual salary pretty easily, but once we get beyond that, it no longer becomes concrete, it becomes just conceptual. So I think I am not uncommon in this inability to grasp large numbers. And the thing is, if you can't grasp large numbers in reference to evolution, you probably are going to have a hard time understanding evolution. Why do I say that? Because we're talking about deep time, the passage of billions of years. And that is the framework that evolution takes place in. And so, let me give you some examples of this. How many days do you think 1,000,000 seconds is? 11.5 days. So, how about 1,000 million seconds? 1 billion seconds. How much time is that? Well, that's 31 years. How about 1,000 billion seconds? A trillion. A trillion seconds is 31,688 years. Big numbers gobsmack us. So, wouldn't it be kind of cool if we were able to make time a little bit more relatable, something more conceptual, less conceptual, more concrete. And here's why. Because evolution happens on a time scale that's in the billions of years. Now, just think of a billion. That is 1,000 millions. Humans have been around for roughly 200,000 years. That's 400 generations. So if I have trouble thinking about 3 or 4 generations, just think of that small time period of 200,000 years compared to the age of the Earth, 4.5 billion years. So what if, in order to make this passage of time more concrete, someone were to lay out a 50-meter tape and said that 50 meters represented 5 billion years. That would mean, let's see, that's 5,000 centimeters, so that would mean that each centimeter would represent 1,000,000 years. So maybe that would make it more concrete. And then maybe it would become more tangible, and the idea of evolution through natural selection more meaningful. Well, that's what I brought you out here for, because lo and behold, somebody has done that very thing. Look, here's the meter tape. And it stretches all the way down there to where that guy is waving. Maybe that's the guy who set this up. So why don't we take a walk through history and see if evolution through natural selection makes more sense. So if this is 50 meters, roughly at 45 meters, that would be 4.5 billion years ago. So 4.5 billion years ago, the Earth is formed. So we're walking from the past to the present, and each centimeter is 1,000,000 years. We hit 4 billion years. Now, along this meter tape, somebody has placed significant life events that have taken place in the past. As a matter of fact, here's the first one we come across. At 3.8 billion years ago, life appears. And this is known as the last universal common ancestor. So quite a bit of time goes by before life appears. Shortly thereafter, not really that shortly thereafter, 3.5 billion years ago, the first photosynthetic bacteria shows up in the fossil record. And this is going to be incredibly important because basically bacteria are going to change the Earth through their metabolic processes. Let's see what the next life event is. 3 billion years. And so it appears that not a lot is going on, but the truth of the matter is there was probably quite a bit going on. The thing to remember about the fossil record is this, that the ocean basins, the ocean crust, completely recycles itself every 200 million years. And continental crust is being weathered and eroded into the oceans. So whenever you're dealing with time this deep, you're going to have a hard time finding traces of life. Let's continue. Oh, look. Some change starts to accumulate here at 2 billion years ago. We see that bacteria become highly diversified, and eukaryotes show up in the fossil record for the first time. And that means more complex organisms, organisms that have a cell wall. Now, let's continue on. Each centimeter is 1,000,000 years. So we are racing through the past 1 billion years ago. And then you'll notice as you look towards the present that there are a lot of life events that start happening. And so one thing to remember about evolution that might be kind of difficult to understand, good characteristics of life get passed on. Things that don't work, and we could characterize them as bad, but they're really not bad, or the good ones not good. Those are just characteristics that confer success. And success is getting your genes into the gene pool. The characteristics that confer success accumulate. So the human eye, in all of its complexity, just didn't pop out of nothing. That human eye is built upon literally billions of years of characteristics that were selected for. So let's look at some of these things that start happening. Roughly 600 million years ago, the first multicellular organisms show up in the fossil record. And look at how fast these life events start accumulating. 540 million years ago, there's a rapid diversification in sea life. So between that 60 million years, this the first multicellular organism showing up in the fossil record, to 540 million years, just in that 60 million years, there's incredible kind of advances by life. 500 million years ago, the first cephalopods, and then 470 million years ago, first plants. 440 million years, first fish. And then 410 million years ago, oxygen arrives at its modern levels, and contemporaneously, life moves on land. So there's some speculation about this, although there's not strong evidence one way or the other. But as oxygen reaches its present level in the atmosphere, and we can thank bacteria for that, because photosynthetic bacteria had been on the planet for literally billions of years producing oxygen. As a matter of fact, we can probably thank bacteria for a lot of things. And maybe even bacteria might be running the show. You know, I've often wondered if bacteria invented humans so that they could go onto other planets. But that's another story. And so whenever oxygen reaches its current level, in the upper level of the atmosphere, there's more opportunity for oxygen to form ozone, be converted from O2 to O3. With an ozone layer, land becomes much more interesting to that life in the ocean that lives under a shield, water, which protects it from ultraviolet radiation. So with ozone in the atmosphere protecting land from UV radiation, it seems like an enormous niche ready to be exploited. So perhaps there's some relationship between oxygen at the modern level and life moving on land. 400 million years ago, first insects. There's a little annotation on this one. Somebody wrote 479 million years ago. And what's true about all of these times that are on this timeline is that they're subject to change. That's what science does. It's dynamic. And so that time, 400 million years ago, has been pushed back through some genetic analysis to 479 million years. So insects have been in the house for a long time. Look, 380 million years ago, first spider. Life starts to get more and more complex. 320 million years ago, first reptiles. 280 million years ago, first woody plants. And so these are plants that have cellulose in their stems and lignins, which gives them a great advantage over the first plants, which were really low-lined, had a low-lined form. If you have lignin, or have access to lignins and cellulose, you're able to get up and above your neighbor and therefore outcompete them for sunlight. So that's going to end up being an important accumulation of positive characteristics. 2 million years ago, the Great Dying. That is an enormous extinction that happened where much of life on Earth became extinct. Let's see what else we have here. Oh, so whenever we think a long time ago, we often think of dinosaurs. Brothers and sisters of the Pale Forest, dinosaurs were not that long ago. 250 million years ago. 245 million years ago, first flowering plants. So it looks like this is a moment where a mutualism between insects and plants appear, which ends up being a pretty magnificent thing. Oh, our distant relatives show up on the scene 180 million years ago. 150 million years ago, first Boyd. And we always think of this as, oh my gosh, that was so long ago. Look, here's the present, friends. 60 million years ago, dinosaurs become extinct. And then once you get down here to the end, kind of in the world of humans, you can't even put them in the place properly, the events in their place properly. 5 million years ago, first hominid fossil. That's right here. 200,000 years ago, humans appear. 10,000 years ago, you can't even get that in there. Agriculture begins. Whenever you think of this enormous passage of time, it seems like evolution through natural selection becomes much more tangible. I'd just like to end this episode standing next to this monster of a tree, and maybe this is a good place to close with the idea of the geological passage of time. We frequently see friends like this and we think, wow, that thing is super old. And it is super old in a human temporal frame of reference. But this tree, probably 300 years old, just a pup. Anyway, I want to thank James Steady Hands Holder for doing the videography on this shoot. And I also want to thank you for watching and encourage you to go ahead and hit that subscribe button, go over to our website. You know there's a lot of good stuff over there. And more importantly, there's an opportunity for you to donate to the Natural History Institute. We are a not-for-profit organization aimed at revitalizing the important practice of natural history, because without natural history, we would not have the great revelation of evolution.